Hello, welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm your host today. My name is Whitney Lee. I'm a senior technical advocate at Datadog, and I'm a CNCF ambassador. So each week here on Cloud Native Live, we bring a new set of presenters to showcase how to work with cloud native technologies. We'll build things, we'll break things, and we'll answer your questions. This week, we have Anusha and Miriam here with us to talk about the future of cloud governance, AI remediation in action. I'm really excited to see what they have to share. So, I have to say, this is an official live stream of the CNCF, and as such, it's subject to the CNCF Code of Conduct. So, that basically means please be nice to each other in chat, please be nice to our presenters, and please be nice to me too. And we'll return the favor. And those of you who are joining us live, please say hello in chat and say where you're here from. I love how we're a part of a global community. I think it's the coolest thing ever. So if you have questions during the presentation, please do ask them in chat as we go, and we'll try to make this feel more like a discussion than a presentation. And with all of that, I'll hand it over to Anusha and Miriam to introduce themselves. Hello, friends.
Hey, thanks, Whitney, for that introduction. Hey, everyone. I'm Anusha. I'm a product manager at Nirmata. I manage Enterprise, Kiverno, and our SaaS offering, which is Nirmata Control Hub. Nice to be here.
So awesome to have you.
Hi everyone, thanks for joining. I am Mariam Fahmi. I'm a Kiverno maintainer and I work as a software engineer at Nirmata. Today we are going to talk about AI remediation in the Nirmata Control Hub. And this is an exciting feature because it helps you to fix automatically the misconfigured Kubernetes resources. But before we dive deep into this, I would like first to start with a quick introduction to Kiverno, and then we will go through a live demo that I prepared. So we will apply Kiverno policies in the cluster, and we will deploy a bad resource that violate these policies. And finally, we will dive deep into the AI remediation in the Nirmata Control Hub, and we will see how this will help us in automatically fixing the misconfigured resources.
Awesome. This
Um,
sounds really fun. Are you ready for me to share your screen?
yeah.
Awesome. Here we go.
With that said, let's get started. So, first of all, what is Kiverno? Kiverno is a policy engine for Kubernetes. So, let's say that you have a use case where you need to make sure that every pod deployed in the cluster have a specific label. For this use case, you can create a cluster policy as shown in this example, and this policy match on pods. And under the validate rule, we define our validation logic to make sure that this specific label, which is team in this example, exists in the pod. And finally, we set the failure action to enforce, which means that Kiverno will block the pod if it violates the policy. So how this works internally? So when the user create a pod, this API request goes to the API server, and then it goes through multiple stages. The first stage is authentication and authorization, where the API server checks who created that API request, and it also checks whether they have the permissions to create the resource in the first place or not. And after that, this API request is forwarded to Kiverno server, and it is the responsibility of Kiverno to fetch all the policies from the cluster and apply them to the incoming resource from the API request, which is pods in our example. And after that, Kiverno returns a response back to the API server, and this response can be like either deny the API request because the pod violates violates the policy, or it can allow the API request, but in that case, Kiverno will generate a policy report to show that this pod violated the policy. Yeah, and that's it. So we can have like a quick look on yeah some different types of the rules. So first of all, as I mentioned, Kyverno provides the validate rule for resource validation, and if you want to mutate a resource, you can use the mutate rule. So here, for example, this policy match on pods, and for every pod created, Kyverno will add the team label set to Bravo. um, this how the mutation works, okay? And we have also the generate rules. And yeah, the generate rules is beneficial when you, for example, have a use case where you need to generate like a network policy, or you need to generate a secret whenever a namespace is created. So you can definitely use the generate rules to generate the resource that you want in the namespace or whatever you want. Um, yeah, with that said, like we have three main rules: the validate and the mutate and the generate rules. They have always been the core of Kyverno. And as usual, it provides, a powerful mechanism to do whatever you want. But at the end, when Kyverno evolves and new features were added, we started to face some challenges. So let's take the resource validation as an example. So for example, you can use the validate.pattern field to specify your validation logic. For example, this policy match on namespaces, and it checks that this namespace has the purpose label set to production, right? We also have different sub rule, which is the deny sub rule. And in the deny sub rule, you can specify a set of conditions, and the incoming resource, if the incoming resource meets any of these conditions, then this resource will be blocked. So this is another way to write your validation logic.
So
And
you can do it in an additive or a subtractive way. You can block everything except these things, or you could block nothing and then block only certain things that come through.
yeah, that's correct.
And I have a question too.
Yeah,
Do
sure.
you talked a little bit about policy reports at the when you were talking about the overall how it works? Does a
Yes.
policy report get generated no matter what? Like if there's a rule for any pod that comes through, does a report get generated regardless of whether that pod is accepted or denied?
So if the pod is denied, there would be there would be no policy report generated for that.
Okay.
But if it is, yeah, if the failure action is set to audit, which means that the pod, even if the pod violates the policy, it will be accepted. Then a policy report will be generated for that.
Okay. So you're keeping track of every single thing that gets accepted into your cluster and under what condition.
Yeah, and we also have, you can control whether you need to generate those reports or not, depending on fields in the policy itself. So we have, let me, yeah, bring it. We have the admission field and the background field. So the admission field means that if it is set to true, which is the default value, it will generate policy reports by default. And for the background, it means that it will generate policy reports for the existing resources too. Like, yeah, it periodically checks if there are any resources violates the policy that exists in the cluster.
I see how that's useful for the first time you install Kyverno to be able to navigate what you already have going. Once you already have it installed, though, what else would you use background for? Or is it only intended for that first use case?
Yeah, it is intended for that use case.
Okay, cool. Thanks.
Yeah. Yeah, and also we have the pod security sub rule. And here, the pod security sub rule aimed to apply the pod security standards to the pod. So here we have pod security standards, and we have three profiles: privileged, baseline, and restricted. And for example, yeah, this policy applies the baseline profile. And as you see here, the baseline profile consists of multiple controls. Let's say first we have the host process control. And the goal of this control is to verify or to check that the host process fields under the security context, whether it's under the containers, initiate containers, or ephemeral containers, this field should be undefined, or if it is defined, then it should be set to false. And there are other controls that have the same goal, like, for example, the host namespaces. It makes sure that those fields must be undefined, or if they are defined, then they should be set to false. So yeah, the pod security sub rule has this goal is it's yeah, its goal is to apply the pod security standards. And we also have cell expressions, so you can use cell sub rule to validate resources, but using cell expression. This is another way to do it. And finally, we have Kyberno JSON assertion trees. Yeah, this is also another way to validate resource. And as you see, we have different solutions or different methods to fix the same problem. And sometimes it's hard to decide which sub-rule do I need. And sometimes also it's hard to decide which fields or which configurations we should configure for our rule type. So yeah, for example, the validation failure action field is under the spec, in the policy itself, but this field actually does have an effect when it is used along with the validation rules. But for example, it doesn't have any effect when it is used with the generate rules and vice versa. So yeah, what I need to say is that Kyberno policies is great, but we need to enhance this a bit. So at the same time, cell expressions were gaining momentum in Kubernetes. As some of you might know, that validating admission policies and mutating admission policies, these two policies were introduced by Kubernetes, and both make use of cell expressions, and also cell expressions are used in CRD validations. So it's quite used in the Kubernetes ecosystem. And at Kyberno, we have believed that policies should be easy to read and write, and we figured that Cell is becoming, more powerful and easy. So we started to, change our way. So instead of having one policy that does everything, we started to introduce new policy types, and this brings us to the validating policy. And the validating policy only make use of cell expressions. There is no other way to validate resource except of cell expressions. So yeah, for example, if we have this policy, as I said, this policy matches pods, and it simply apply the baseline profile on the pods. So yeah, just to be clear, if the pod, for example, has this field set to true, then this policy will block the pod, right? And why will it block the pod? Because the failure action is set to enforce. If it is set to audit, this means that even if the pod violates the policy, it will be allowed and policy reports will be generated.
So we have this question again, which I kind of asked before, but so in this case that you just mentioned, if it gets accepted, even if it violates the policy, but it's in audit mode and gets accepted, it's going to go into the policy report. But
Yeah.
if it's denied and not accepted in any case, then it will not be in the policy report. Correct?
There will be
Cool.
no, yeah, there will be no policy report, because the aim of having policy reports is to show the current state of the resources in the cluster and whether they violate any of the policies or not.
That makes sense.
Yeah. So Now we need to convert this cluster policy to a validating policy. And as I mentioned, baseline profile has lots of controls. And when we use pod security subrule, all these controls are checked once. But for validating policy, it's a bit tricky because you need to write a cell expression for each control. For the sake of this demo, I have just prepared three samples for three controls, but don't worry because Kyverno policies library have policies for all the controls within each profile, so all the cell expressions are already uh, you know uh, are exist in the library, so you can have a look whenever you want. And if you have any questions, yeah, I would be grateful. Okay, so yeah, for the first policy, we have the validating policy, and the purpose of this policy is to disallow host path. Okay, if we look, if we look at the host path quickly, yeah, here is it. We have the host path volumes, and this control forbid, the usage of host path volumes. So it checks that the host path field is undefined. So how do we achieve the same behavior using cell expressions? So first of all, this policy batch pods, and as you see, we have the validation action set to deny, which means that if the pod violates the policy, then it will be rejected. The request will be blocked. And this is the validation fields where we write our cell expressions. So the cell expression first states the object. The object here refers to the incoming resource from the request. So here the incoming resource is pods, right? Because this policy is only applied to pods. And then we access the spec field of the pod, and after that we access the volumes field if exist. And the here, if you know, if you yeah if you are seeing this is if you are see this clearly, we have a question mark which indicates that this field, like which indicates like if the volumes field exists, then we will do something, right? If it doesn't exist, what happens? Then we will return an empty list. Okay.
We have we have a question in the chat. So we're talking about pod security. And so someone's asking how this relates to a runtime security system like KubeArmor that's using eBPF to look at system calls.
I think those two are different things, but yeah, I'm not entirely sure.
I think KubeArmor is looking at the process level. KubeArmor doesn't know about the Kubernetes abstractions, if I'm not mistaken. So I think KubeArmor doesn't know about a pod, but instead it's looking at system calls and what's happening at the kernel level. And this is a little higher on the abstraction levels. But that's a great question, Amit. Thanks for asking it.
Yeah, they are totally two different things.
Mm-hmm. So
Um, yeah. So yeah, this cell expression can be read as if the volumes field exists, then we will loop through these volumes, and for each volume, we will check whether the host path volume exists or not. So if the host path volume exists, this means that this part of the expression will be evaluated to true, and then we use the negation operator to make it false, and as a result the whole expression will be evaluated to false, and since the pod violates the policy it will be blocked. And we have a bad pod here, which as you see defines the host path volume, which makes this pod violating the disallow host path. And the second policy is the disallow host namespaces. And if we check this, we will see that host namespaces control check that those fields must be undefined, or if they are defined, then they should be set to false, right? And again, we in this policy we are matching on pods, and we have a variables section, which is totally optional. So the benefit of this is like to make, instead of having a whole long expression in the validation part, we are just like dividing the expression into parts, and then we use these variables in the original validation expression. So here we have a host network variable, and this variable is has this expression. So we option if the host network is defined, then we take this value and assign it to this variable. But if it is not defined, then the host network variable will be set to false. And the same with the host IPC and the host PID. And finally, we have the cell expression that is evaluated when a pod is created. So here we are saying that if the host network variable is set to false, or if it is set to, or if the host IPC is set to false, and again, or if the host PID is set to false, then this part of the expression will be false, and then we use the negation operator, and the whole expression will be true. And this means that the pod doesn't violate the policy, right? Because all these fields are set to false. And yeah, we can show like, yeah, this bad pod. As you see, we have the host PID set to true, and the other two fields are set to false. And if we return back to the expression, the host PID here will be true, right? And the whole expression will be false, which means that the pod violates the policy and it will be rejected. Finally, we have this policy, which is called disallow host ports. And yeah, this policy match on pods. And as you see here, we also define a variable which is called all containers. And yeah, this variable, the aim or the goal of this variable is to have a list of containers, right? We can have initiate containers, we can have ephemeral containers, and of course we have the containers itself. So this variable will have a list of the containers, and if the initiate containers exist, then it will have also the list of the initiate containers. And yeah, again, with the ephemeral containers, if it exists, then we will have a list of that. If the initiate containers field doesn't exist, what will we return? We will return an empty list. Okay. So here, yeah, in the validation section, we are looping through the containers. And as you see here, we are using the variable, right? And for each container, we are checking if the ports field exists. So to imagine that, we have initiate containers here, and we have ports, which is also a list, right? So if the ports field exists, then we are gonna loop through this field. And for each port, we are checking if the host port field exists or not. For example, this pod define the host port, right? So we get this value and check if it is set to 0 or not. If it is set to 0, this means that it doesn't violate the policy, right? But if it doesn't set to 0, this means that this part of the condition will be evaluated false. And as a result, if this is evaluated to false, then the whole expression will be evaluated to false too. And again, this means the pod violates the policy and it will be rejected. With that said, I think we can start applying these three policies and see them in action. So yeah, I have a cluster deployed, and I of course installed Kyberno. We have the 4 components here. So I will first start by applying the 3 policies.
So you said earlier that a lot of these are available, like the community is written, and you can have a lot of policies that already exist that you don't have to necessarily include this logic in your own.
Yeah, in the policies library, we have
Mm-hmm.
a lot of policies here for,
Ah,
yeah, we have generate, mutate, validate, and we also have a PR for the validating policies sample. So yeah, it will be merged soon, and we will have all these in the library.
excellent.
Yeah. So yeah, after we applied the three policies, we assume that if we try to apply this bad pod, it will be blocked, right? So let's try to apply it and see if it is locked or not. Okay, so here, as you see, that yeah, the admission webhook rejected the request because the policy disallow host path failed. Okay, and yeah, it shows you the message that you have uh, declared in the policy itself. And we also have the disallow host namespaces policy also, you know, yeah, the pod also violates this policy. And finally, it also violates the disallow host ports policy. We can see if we can, like, we can, yeah, sorry, I don't know what I'm doing. Yeah, I just want to show you the policy reports so I can um, yeah, set the validation action to audit instead of deny, so that you can see in action that the pod is created, but we have policy reports generated as a result. Okay, I forgot to update the policies. Okay, yeah, it's bad pod. Yeah, we will see that the pod is created, although it violates the three policies, right? We can now check. No, it's not cluster. Yeah, we can now check the policy reports. I think we need to give it like few seconds till it's generated.
So it got created because it's in audit mode. If it was in force mode, you would not get created because
Yeah,
it violates.
that's correct. And also, if the pod doesn't violate the policy, we and it is successfully created, we will have a policy report indicating that this pod, has a pass result.
And who can see that policy report? The person who sees it.
This is a good question. So actually, when the policies are in audit mode and you don't want to block all the incoming resources at once, you can check. You can test. You can test it and see what existing resources violate them, and accordingly, you can enhance or configure these pods step by step until they don't violate the policies anymore. So yeah, it has a lots of use cases for the policy reports. And also Kyverno has like a policy dashboard. You can reports dashboard where you can connect to it and see those reports in dashboard instead of like, yeah, getting it in the cluster.
Cool.
So yeah, this is the policy report. As you see, the report is generated, and we have three results. So the first result saying that as a result of applying this policy to the pod, which is here, the result is fail, and the same for the other two policies. And overall, we have like a summary section. It shows that we have three policies, three policies that this pod violate. Yeah, and I would like to show something. Yeah, if it's okay. Let's say the disallow host path. Yeah, so the disallow host path match pods, right? And we have validation expressions for that. What if we want to apply this policy to the pod controllers like deployments, stateful sets, daemon sets, etc.? Do we have to rewrite those cell expressions again for the other pod controllers? And the answer is no, because here we have by default there is like auto-generated rules for the pod controllers. So for example, in the status, under the status, we have an autogen field, and for the cron jobs we specify that the match constraints are cron jobs. And as you see here, the expressions are modified a bit so that it can be applied to cron jobs as well. And here we have another rule which match daemon sets, deployments, replica sets, stateful sets, and we also match jobs. And as you see here again, the cell expression is modified a bit to be able to apply on the pod controllers too. So yeah, if we like this is an example of a bad deployment. So if we, yeah, we can change this back to deny so we can see it in action. Okay, if we try to apply this bad deployment, we will see that it is blocked too, even though we didn't specify it in the match constraints.
Where did you specify it?
So we don't specify the
Uh-huh.
deployments. We just specify the pods, right? And
Oh, okay.
yeah, and by default, Kyverno auto-generate these rules for us. So it's under the status field. Like we have two sections: the first section for the cron job and the second section for the other pod controllers. And it does like the any updates we need to make for the cell expressions. It's updated by Kyverno itself.
So
So
it's because the resources there are going to create the bad pods eventually. We're catching it earlier. Is that what's happening?
um, no, I mean, if we need this policy to be applied to deployments too, we don't
Uh-huh.
have to rewrite the cell expression because the bad pod here is
Uh-huh.
different. Yeah, the pod specification is under the template in the
Uh-huh.
deployment. So
Got
if
it.
you want, sorry, if you want to apply this cell expression on
Uh-huh.
deployments too, you have to specify object.spec.template dot, you know what I
Uh-huh.
mean?
Yeah.
So yeah, Kyverno does this for us. So it automatically updates the expression so that it will be applied to deployments too.
I get it. That's very helpful. Thanks for describing it a little more to me.
Thank you. Yeah, and that's it. So now we will see how we can use the AI remediation in Nirmata Control Hub to fix these bad resources.
Is it time for Anusha to come on?
Yep.
Thank you so much, Miriam. I appreciate you. Hello,
Thank,
Anusha. Welcome. Are we
Hey,
saying goodbye to you, Miriam? Or you said you have somewhere else you need to be?
yeah.
All right. So goodbye and thank you so much for taking your
Take care.
time
Bye
today
bye.
to share with us. Bye. Welcome, Anusha.
hey, yeah, thank you. Yes, Mariam had to go elsewhere, but isn't it always nice to hear new things directly from the maintainer? Like, absolutely loved it.
Me too.
Um, cool. So what we saw so far was, we have a bunch of Kyverno cluster policies. We looked at few pod security examples. But Kyverno 114 tries to consolidate all these different ways to express similar conditions. So it was becoming difficult to keep track of how to even write a new policy because we've had like lots of users and customers ask what's the best practice, right? And ultimately, even we were falling short of the answer. And when Cell started gaining more traction, it is becoming more and more prominent in Kubernetes. we decided to just make that as the standard language for Kiverno. So with 114, you'll be seeing a lot of, more and more of cell. And it's recommended that once you move to 114, you need to, migrate all your policies, because as you can see, there's just a lot of breaking changes. It's currently out in alpha, but do try it out, give us feedback, and, so that we can get to GA quicker. Cool. So with that, I want to switch gears to Nirmata Control Hub. We looked at violations. There was a lot of failures when a policy was in an audit mode. And I think earlier also there was a question whether a policy report is generated just for the pods that are accepted, right? Rightly so, because we want the current state of the cluster to be reflected. And for the ones that are denied, we generate events for that, so that you know which resources got denied. But it doesn't make sense for us to create a policy report, because that resource will not exist in the cluster at all. Um, but, and also, while it is a good practice to have your policies in enforce mode, what we've seen is not every team out there is comfortable in introducing a policy in enforce mode, because they don't want to block developer workflows, and it just causes too
You don't
much.
want to break stuff. Yeah,
Yeah, you don't
absolutely.
want to break stuff, especially if you're introducing Kiverno in a brownfield environment where things were working, and now you don't want policies in enforce mode. So the best way is to always introduce Kiverno policies in audit mode. Take a stock of, how your resources are performing, like whether they're passing or failing. Once you have enough confidence that all your test results are passing, then you can safely switch to enforce or continue to be in audit if that's what you want. But like you saw, with just one deployment, we ended up with reports for replica sets, pods, deployments, and that's just for one workload, right? But in a typical and enterprise, you will have lots of clusters, lots of workloads, eventually lots of policy reports. So how do you keep track of all these reports? And ultimately, somebody needs to fix those. It's not useful if you just say something is failing or something is violating a resource. The point of all this is to ultimately fix it and be secure. So Whitney, you asked this good question early on who actually uses this policy report or who sees this report, right? So I think that depends on your role, your job, because Nirmata Control Hub here is targeted mostly for platform engineers, or maybe DevOps, DevSecOps, whoever is responsible for maintaining these clusters, whoever is responsible for coordinating workloads to be deployed in these clusters. They typically run GitOps, they run Terraform to provision these clusters, and ultimately they are responsible in managing clean environments. So they can use Control Hub to view all of their reports all in one place. So for example, this is a Nirmata Control Hub dashboard. Here, this gives you a quick overview of how many clusters are onboarded over here. This is cloud provider agnostic, so you can have any cluster over here. Even your local client kind cluster, you can register to Control Hub. The number of policies that are passing, failing across all your environments. So this kind of becomes that management pane where you can get that quick information of your security posture of your Kubernetes clusters. So
I have a question real quick. I think Miriam mentioned a UI that Kyverno has. Is this
hmm?
that, or does Kyverno also have a UI?
Everyone also has a UI. It's called Policy Reporter, which is the open source project.
Okay.
Uh, okay, there's a website. So basically, you run Policy Reporter in every cluster, and you get a view of how many, what all policies are there, what's the status of it. But this is going to be per cluster. This is you can try this out, use this in maybe lower level environments. What we as Nirmata recommend for production environments is Control Hub, because now you can register multiple clusters all in one place and try to correlate, if something went wrong, how it relates or affects other clusters or namespaces. coming to policy reports, so the same policy reports that you saw in the CLI, uh, we use the same backend schema because policy report is a standard by the policy working group in CNCF. They have defined the schema and we use that as well. So policy reports, now you can categorize it. You can group a set of policies together like pod security restricted, there's RBAC best practice, or maybe you have even compliance controls like DISA compliance or CIS. So all of these compliance standards have a bunch of controls. You can map these controls to Kyverno policies and uh, get that view over here. I can view policy reports on a cluster level, per cluster level. If I'm a platform engineer, I know that now I have this demo cluster on for CNCF webinar. I assigned a grade because of there are certain failures in this. I can have a AWS cluster here. I can have AKS, anything. So as a platform engineer, I know which cluster has the most violations, which cluster is like maybe doing okay, something is A plus. That's awesome. I
You
can
said you assigned a grade, so you defined like what's good and what's bad for your particular organization.
sorry, did I say I assigned a grade? No, I did not assign a grade.
Oh,
The
okay.
control lab assigned the grade
Okay.
depending on how many violations or failures are there in the cluster. Like the more failures, lower the grade.
Okay. Thanks.
And you can also view this on a per namespace level. So there are different namespaces which belong to different clusters. Now, as a platform engineer, I have a complete view of all my clusters and all my namespaces, right? But like the goal of this webinar today is to see how we can get to fixing the different violations. So again, it depends on every organization, I would say. Like sometimes the platform teams are responsible for fixing these manifests so that they comply with the policies. But in some organizations, I've seen that individual development teams are responsible for their namespaces. Let's say I'm using namespace as a service. We have a multi-tenant system where my team owns the app namespace. There's some other team that owns maybe OpenCOS namespace or Nginx namespace. As an individual developer in a team, I probably don't need to know what's happening in other namespaces. I don't need that visibility, right? So in Control Hub, you can add owners. The owners are typically individual developers or teams that you can add. And right now I've logged in as an admin so that I can see everything. But if I had logged in as an individual developer, my view would be very much limited to the access that I've been given. Basically, it's RBAC. So let's now focus on our CNCF cluster and my app namespace where I have a few resources. I just have one Nginx deployment with 2 replicas. And there are some failures here. There are 3 failures in each of them. So earlier, Miriam showed that even though the policy was for the pod, and when you run a deployment, it generated failures for deployment, replica set, and pod because Kyverno auto-generated all of these rules for higher level controllers. So similarly, what we'll do is we'll actually fix the deployment. We're not going to fix the pod because it's being controlled by a higher order controller. So we'll fix the deployment instead and see that how just fixing the deployment manifest actually reduces all of the violations here as well. And for that, Nirmata has introduced recently a newish feature, I should say, because this is out for a month, I guess now. And this is available in preview. I think Whitney has already shared the sign up link. So there's a free trial available if you want to try it out. So what Remediate does is basically, now this is the original resource. So this is the resource that I've deployed in my cluster. And this is the remediated resource. So it looked at all the violations on my Nginx deployment. And then it suggests these are the possible fixes that you can look at in order to comply with all the policies for this resource. So again, we use AI for this. As much as we want to believe AI is a magic wand, we highly recommend that you test these before actually deploying this to cluster. And for that reason, we don't even allow the option to directly deploy. because we want you to test it. If you're following GitOps practices, that's awesome. We want you to create a pull request, get it approved, and only then put things into your cluster. So here it gives you an explanation of what changes it made. This is very useful for, say, development teams or even platform engineers, right? This cuts down the time to fix a particular violation, because earlier, uh, when you look at a violation, when you see that, the violation is something like you cannot have this capability. Now you have to go figure out what is this policy, what exactly it is checking, why my deployment failed. You have to go look at your deployment and then maybe reference Kubernetes documentation on what's the best practice, what are the allowed values. It just takes a lot of time. Like, although you can do it, it might take you 2 days, 3 days, depending on how complex the policy was and how complex is your deployment. But this gives you a very, I'd say, like a quick start or that help that you need, just to take that first step. Now you know these are the configurations that were missing or incorrect, and you need to add those. But it's still recommended that you try this out. So what we do is we'll just download this for now.
That's what I like AI for in general, is just getting me to over that first hurdle of starting or understanding and then fine-tuning it from there.
Yeah, definitely. Like, I think we should use it as a partner or a pair instead of
Mhm.
expecting it to do our job for us.
Yeah.
Okay, so I have my Nginx deploy, which this is the original resource that's running in the cluster. Okay, so this is running, and now uh, what do I want? Okay, I have downloaded the remediated resource. Let me just copy it over from downloads. Okay, I have the remediated resource. This has all the fix that was suggested here. Let me just apply this. Oops, happened. Invalid patch. Always happens during a demo, isn't it?
Yeah, unknown field, spec template, spec containers.
Icon profile. Maybe it was wrong in some indentation. Let's try to fix it. That's why you always run whatever the AI suggests. Okay, let's just remove this. I don't know what the correct indentation is for now. Let's try to apply. No,
No, look at the
I
very
think this,
last. Oh, unknown field spec dot template dot spec dot containers, the first one.
yeah, spec field, spec template, spec containers. Yeah, spec template, spec containers. I'm
Hmm.
surprised why it says unknown.
Yeah. Let's see.
Okay, let's try it out again. I mean, not this. I want to maybe create a new namespace and try that so that I don't run into old data. Okay. Okay, not in the app namespace. Okay, now let's get this. Okay, I have the pod running. Yes.
I like up top, we promise to break things. I'm always a little disappointed actually when we don't break things. So thanks for keeping me true to my word.
um, okay, it should be okay. Now we have the policy reports generated in the webinar namespace. Let's go check here. Did it get populated? Uh, over here. Okay, it takes some time to sync. Let's wait a few more seconds. In the meantime, I can show around. Um, So yeah, so once we are in this CNCF webinar cluster, I can again view all the resources that are there here, or I can look at all the findings. Findings are basically the policy rules that failed, because I mean, nobody cares about the past ones because we want to focus on the failed ones and fix them ASAP. They're different. What are the policies in my cluster? I have all the PSS ones deployed. Coming back here. Okay. Now this is my webinar namespace. Going to the resources. Fine. The Nginx deployment has 3 failures, almost same as before, but let's see if it works now. So it says it's failing 3 of the policies. I honestly don't see much difference, but okay, there must be something different, hopefully. Okay, let's download this. 18.5. First, let me remove this so that I don't mess up.
Will you
Okay.
will you clear so that at the terminal
Yeah.
is at the top? Yeah, thanks.
Yeah. Yeah. So now I have the remediated resource, which I downloaded from here, and just double checking whether it didn't change any of my namespace. My namespace is still a webinar. The only changes is these configurations to comply with the policy. All right. So, yay. Okay. Now it said it configured, but let's see, are my pods running? Okay. Say 7 seconds. So it created new ones. So it means whatever the remediation suggested here actually works and my pod is up and running. Um, I again, stress the importance of testing these remediations, because let me show you why. Because I always run into this example, and I mean this problem, and it's quite common. Is right now I'm using a Bitnami Nginx image. This you can run this as not root. It does not require that permission. But if you download an Nginx image from say docker.io, it requires to be run as root. And one of the PSS controls says that, run as non-root should be set to true. So our suggestion would be, in order to comply with the policy, you need to set it to true. But now, depending on your application, your app needs it, right? So your pod will not come up. Your pod, I think, goes into crash loop, or there's some, it gets stuck in an error state. So it means even with the remediation, you are breaking your deployment. So when suggesting these correct configurations, Kyverno does not know the intent of your app or what you're trying to do in your app. So it's always recommended that you try it out first in a sandbox environment or a test environment. Okay, now let's look at the policy report. Yes, I have pod deployment. I have 0 failure now. This particular one is a previous replica set, because by default, Kubernetes maintains like 10 revisions of replica sets. You still see the older ones here, but the newer replica set has 0 failures. And also, I think from an earlier question, like why, policy reports only for the resources that are generated, you can also see that the policy report is anchored around the UID of the resource. So if your resource was denied, your resource doesn't get created, it does not have a UID, and therefore also no policy report. Okay, so we have 0, 0. Let's go back. My grade was B for this namespace, but I
want
want
an
to
A
see again.
plus.
Let's see. Okay. Let me try to go back. Okay. Yeah, here. Yay.
Oh,
Your
A
wish came
plus.
true. Yeah. But we still see these 3 failures, but that's from an older replica set. So if I come here, the older one is still here. Ideally, we should not be showing, try to fix this because you cannot realistically fix that. Uh, the only thing you should be focusing on is the deployment, and all of them are zeros. And now everybody is happy. You can go start fixing other, violations. Yes, I think I had. That's all I had to show about fixing violations with AI powered remediations. Again, don't forget to test it out. So ideally what you would do is try it out in your sandbox cluster. If you're using GitOps, create a PR from here. You already know what the correct file should be. Just create a PR, get it approved, and deploy it.
Excellent. Is that the end of your presentation?
I think so, yes.
Wonderful. I'm going to stop sharing your screen now. We don't have any questions in chats, but we do have some applause in chat. So good job. And this has been wildly fun. So thank you everyone for joining today's Cloud Native Live episode. It was great to have you here, Anusha, and it was great to have Miriam too, teaching us about the future of cloud governance using AI remediation in action. Thanks everyone who asked the great questions in chat. I always appreciate that. And here at Cloud Native Live, we bring you the latest in Cloud Native code on Tuesdays and Wednesdays at about this time, which is noon US Eastern. So thanks for joining us today, and thanks to those who watched the recording, and I'll see you next time. Goodbye.
Thanks, everyone.